Alrighty. Hey, Honors Chemistry. So in this video, I'm going to briefly go through some slideshow notes, and just a note, while watching the video, record notes in your notebook. If I mention anything that is not in the slides, typo of course, make sure to record that. Notebook notes will be checked on Monday in addition to the post lab for sticky tape. Okay, so we're just going to talk about the periodic table in these notes and then different types of elements and how they form different types of compounds. So you will need your periodic table, and eventually by the end of these slide notes, you're going to be able to look at the periodic table and identify 3 different types of elements. You'll see that there are nonmetals and metals, and then eventually something known as metalloids. Okay, so first, when looking at the periodic table, we have groups or families. They are the vertical columns. Elements that are in the same group have similar chemical properties. Period or horizontal row, we got left to right. So up and down is our groups or our family. Left and right are periods or rows. Now again, if I move too fast, you could always pause the video and record, just letting you know. Okay. Now, the 3 different types of elements are metals, nonmetals, and metalloids. So we've talked about elements in this class, and so now we're going to identify 3 different types of elements, and this may sound familiar. We have metals, nonmetals, and metalloids. We will eventually color the periodic table, but what I would suggest, and you could do this for Monday, is if you color your periodic table very similar to this way. I make all my metals one color, and you can see where all the metals are. I make all my nonmetals another color, and then of course I have something known as metalloids, which act as both metal and nonmetal, another color. So you might want to pause and color your periodic table using any crayons or markers you have in the same way. We want to talk about how metals and nonmetals interact or dissolve in water, so just watch this little video here. I have sodium chloride, which is an ionic compound. It contains a metal and nonmetal interacting with water. As it interacts with water, the negative end of sodium chloride NaCl reacts with the positive end of water, and the positive end of sodium chloride reacts with the negative end of water. We're going to need this because we just talked about charges. So some physical properties of metals. So we might know this already, but metals are good conductors of electricity and heat. They're malleable, which means they could be hammered into, sorry, this got cut off, into thin sheets. And they're ductile. They could be drawn into wires. And they are lustrous, which means shiny. Some chemical properties of metals. They easily lose electrons. We just learned about electrons from our sticky tape lab, and Thompson helped us discover this. Metals will be the ones that lose electrons, and they become positively charged ions. So make sure that you know that. Write that down. Metals easily lose electrons, and they typically form positive ions. What I showed you in the video was I had a compound that had a metal and nonmetal together. The sodium in the sodium chloride readily was positive and attracted to the negative end of water. Some physical properties of nonmetals are quite the opposite of metals. They don't have luster. They're dull in appearance. They are not good conductors of heat and electricity. They are brittle, and they're not ductile. They're not malleable. They break apart into tiny pieces. They can't be bent easily. And they have a low density. And they have low melting point of metals. They have lower melting point than their metals. Okay? And the chemical properties of nonmetals tend to gain electrons. They form negative ions. This is the opposite of metals. So, as I showed you in the video earlier, very quick video, I had an ionic compound. We called it sodium chloride. We had sodium, which was the positive ions, and we had chlorine or chloride, which is the negative ions. Those negative ions were nonmetals, and they reacted with the positive end of water. So make sure you know that on the periodic table that most of your nonmetals will form negative ions. Okay? And going back to our model of the atom, we used to just draw our particle diagrams as circles, but I could have 2 different types of charges now, right? My atom could be overall positive charge, and we call that a cation, or my atom could be overall negative charge, and we call that an anion. These are known as ions, different ionic charges. Positive ions are known as cations. Negative ions are known as anions. And you might want to write these definitions down. And then, so if I lost electrons, I became a cation, which is a positively charged ion. And if I gained electrons, I became an anion, which is a negatively charged ion. And an ion is a charged particle. So make sure you know that. I have cations, which are positive ions. Ions are charged particles. Anion, which are negative ions. Ions are charged particles. Okay? Last thing we'll talk about, if I put a metal and non-metal together, I will get what I will known as an ionic compound. Ionic compounds like sodium chloride, your table salt, will have high melting points. When they are molten, which means I melted, or dissolved, they can conduct electricity. And yes, there's a way for me to melt sodium chloride. I would just need really, really high temperatures to melt solid sodium chloride. There's a way for you to melt your table salt if I could get really high temperatures, and that would conduct electricity. But sodium chloride alone will not conduct electricity as a solid. So just a little schematic about conductivity. Things with ions, positive and negative ions, cations and anions, will conduct electricity. If I have no ions, like water, water does not conduct electricity by itself. It's got to conduct electricity with ions. Water will not conduct electricity because there are no positive and negative ions found. Sodium chloride by itself will not conduct electricity. It's got no flowing positive and negative ions. Maybe they're stuck within the solid structure, but it's not going to be flowing through the solution. Finally, if I dissolve sodium chloride in water, I'll get positive and negative anions. My light bulb will go on, and I can conduct electricity. So we are going to stop here with our notes. Make sure you've recorded these notes in your notebook about the different types of elements, metals, nonmetals, and metalloids. Mostly know the difference between metals and nonmetals using the periodic table, and some properties about metals and nonmetals to distinguish the two of them. On Monday, you will have an open notes quiz about the periodic table and identifying metals and nonmetals and distinguishing their properties.